Chapter 4, Selections, Part 2. I'd like to start by revisiting this problem from last time, which was a subtraction problem practicing for maybe elementary school students. The problem said that we need to generate two random numbers, each between 1 and 9. We then want to present the problem to the student, to the user, but before doing so, the storyline, maybe it was silly, it said that we want to guarantee that the resulting answer will never be negative. Meaning, if we ask the student what is 5 minus 3 and the result is a positive answer, that was okay. If we ask what is 5 minus 5 and we even get 0, that was okay. But if we were to ask 3 minus 5 and get a negative answer, the storyline said that the students, couldn't handle a negative number, which seems crazy. The purpose was simply to practice additional if statements. So if the first number generated was smaller than the second number, we wanted to swap those two numbers. The other purpose of that request was really just a reminder on simultaneous assignment, something that we haven't covered since maybe chapter 2 or chapter 3. So we want to generate these two numbers. We want to guarantee that num1 is at least greater or equal to num2. If it's less than num2, we need to swap them using simultaneous assignment. We're going to then present the question to the user, scan their answer, compare their answer to the correct answer, and then print an appropriate message to them. So here, this was a discussion on the slide of what I just covered, and then this is what we're looking for as output. Print the following: 4 minus 1 equals 2. That's, of course, incorrect. The correct answer is as follows: 4 minus 1 is 3. So if they get it incorrect, we want to reprint the question with the correct answer so the learner, the student, can look at it, see the answer, and hopefully do better next time. Please answer the following: 9 minus 4 equals 5. If they get it correct, we say as much, and then we give them a nice message. Great job, go team, let's go. So this was the sample execution. That's great execution here of this slide to put that up after already seeing what's on the slide. So implementation. This is what we saw last time. In order to generate the two random numbers, we need to first import random. We covered that. And then how do we generate two random numbers? We use the randint function within the random library that we're importing, this random module. You can call it a module or library. Usually module is what we'll say. We've imported the random module, and we're going to use the randint function that is inside that module. And if I were to delete, for example, this and run it, that won't work because Python says, I don't know what random even is right here. And you say, oh, no problem, let's get rid of random. Well, then Python's going to say, excuse me, I don't know what randint is. What is that function? I've never heard of that before. And you're like, well, it's inside the random module. And you're like, okay, I got you. But even still, Python says, I don't know what randint is. Because you have to come over here and specify randint is inside, damn it, that random module. And so you have to type the actual module, and then you put a period, and then you type the name of the function afterwards. So here, this is generating two random numbers between 1 and 9, inclusive of 1 and 9. So it includes both of these numbers. Then what we do is we check if num1 is smaller than num2. So if when we generated those two numbers, maybe num1 was 4, num2 was 7, we don't want to ask 4 minus 7 as part of that storyline, right? We don't want to result in a negative number as an answer. So if num1 was less than num2, we swap them. The whole purpose here was just to practice another if statement, as well as maybe more so as a reminder of simultaneous assignment. How do you swap two values in Python? If you're given, A is 3, A is 4, B is, let's say, 5, we want to swap them. It's as simple as A comma B equals B comma A. And now A will have the value 5 and B will have the value 4. So now step 3, we want to prompt the user to answer the question. So please answer the following. And we save their answer into the variable user answer. And you notice that we print the question within the input statement, even using formatted printing, which is fine. So we printed this question, something minus something space equals space, and then we put the two somethings that we want to go inside those placeholders, num1 and then num2. We're going to scan it as a string. We're going to then convert their answer to an integer. And notice here, when we're ready to print the results, the first thing I do is I computed the correct answer. I said the correct answer is num1 minus num2. Remember, this is an assignment. We're going to take num1 minus num2. We're going to compute that result, and we're going to assign it or save it into this variable correct answer. Finally, we just check if the user answer equal the correct answer. Remember, we're checking equality. We can't do this. That's an assignment. That's not going to give us what we want at all. Remember, this is an if statement. What must come inside an if statement? If something colon, what must this something be? It must be a Boolean expression, which is an expression that we must evaluate to true or false. So here inside this if statement, we say if user answer equal, that's testing equality. If it equals the correct answer, perfect, we print correct, great job. Else, if it is not the correct answer, so let me even put some comments. If the user's answer is correct, we'll do that. And then else, the answer was not correct. And I'm going to put in just a visual space here. It's unnecessary, but just to separate that so visually we can see the if and else very clearly. Else, the answer was not correct. So we have an else colon, don't forget your colon. We print incorrect, and then we print the correct answer is as follows, and we go ahead and print the entire string showing the answer. Something minus something equals something. And what are those three somethings? Num1, num2, and correct answer. Not the user's answer, because the user's answer, if we make it to here, the user's answer was incorrect. We don't want to tell them the correct answer is and put the incorrect answer. So let's run this code. Please answer the following. 8 minus 8, 0. Correct. Great job. 8 minus 3 is 4. Oh no, I'm so sad. It doesn't work. We got the incorrect. The program works, but we got the incorrect answer. The correct answer is as follows. 8 minus 3 is 5. Let's do it again. 9 minus 7 is 2. Let's go. We feel so special because we answered that correctly. It's a pretty easy problem, I hope, to answer for most of us, and hopefully a straightforward program. So this was just a reminder of that as like a warm-up before we now get to the two-way if-else statements as some checkpoints, and we want to code up some things here and see if we can do this. Pause the video when you read this question, and before you see the answer that I'm going to show you, try to see if you can write this on your own. Write an if statement that increases pay by 3% if the score is greater than 90. Otherwise, we increase pay by 1%. Meaning, imagine you're an employee and there's an exam that you have to take, and if you score greater than 90, pay will increase, your salary will increase 3%. Otherwise, you still get a 1% increase. Not very much, but you get a 1% increase regardless. So pause the video and see what you come up with. And now I'm going to go ahead and show you an answer. So if the score is greater than 90, I think some may have put greater or equal to 90, but it only said greater. If the score is greater than 90, what do we want to do? We want to increase the pay by 3%. So this is one way that I could have done that. Pay equals pay times 1.03. Now I imagine we may have had a lot of viewers who would have done this, a lot of learners who would have come over here. Let me open up the garbage program. Let me just hit open garbage. And I imagine we'll have this. If we have, we had score and pay, right? So if score is greater than 90, so score, let's say it was, sure, let's pretend it was 90. And we don't need to actually put these in here, but I'm going to put the score so it doesn't show an error. Pay, let's start the pay at $60,000. All right, so if score is greater than 90, we want to increase the pay 3%. So pay equals pay times 1.03 is what I just showed you here on the slide. Now I imagine some students would have said, well, pay equals their original pay we had plus pay, and they'll do this, maybe pay times 0.03. So this is going to be your increase of 3% plus your original pay, and we're going to determine all of that and then save that or assign that back into the pay variable. That works just fine, but I just want to show you, if you were given this in algebra and you realize, well, we have this term and we have this term, and this is multiplied together, right? We really have pay times 0.03. What can we do? We can remove, or we could factor out pay from both terms. This is now algebra, but pay equals, I could factor out pay from both terms. I'm going to get 1 plus 0.03, which is really pay times, and this would have been a times here, right? Pay times, and then if you add 1 plus 0.03, you get 1.03. So that's how I came up with this. Else, we increase pay by 1%, which is pay equals pay times 1.01. But notice what I did this time is I used the augmented operator as a reminder. So here's what we have. Pay equals pay times 1.03. But that statement is identical to the statement times equals 1.03. And we've covered that previously. That's the augmented operator. A lot of times new programmers won't use that as oftenly because they're just more used to typing out pay equals pay times something. But this is a shortcut. What does that shortcut mean? If I gave you x equals 5 or 4 and I want to add 1 to 4, I could say x equals x plus 1. This is an assignment statement. We come to the right. It says take the previous value of x, which is 4, add 1 to it, and we're going to get 5. No harm, no foul. But it's quicker to say x plus equals 1. That statement really says, what does that plus equal mean? It says take the previous value that's in this variable, which is x, add 1 to it, and then save it back inside x. That's really what's going on. Those are identical statements. So therefore, it's shorter, easier just to do this, and then we have our else pay times equal 1.01. All right, so we should be comfortable with both of those, but augmented operators, of course, will save us some time. We love saving time, right? Another one, what is the printout of the code in A and B below, that we'll see in a moment, if number is 30 and 35 respectively? So we'll look at A first, and we'll look at 30. If number mod 2 equals 0, if, and so if number is 30, if 30 mod 2 is 0, what does mod 2 check? It checks if it's even. So when we divide 30 by 2, is there a remainder? Nope, there's not. So we're going to print number is even. But notice we're also going to print number is odd, which of course 30 is not odd, but it is going to print. Why is it going to print 30 is odd? Because this print statement is not indented over, right? It's not inside the if statement, and there's no else. So it's kind of weird. We're going to say, yeah, 30 is even is what's going to print, and then it's going to print 30 is odd, which is not what we're expecting. Now come over and test this one. If we put 30 in again, if 30 mod 2 is 0, it is. So we're going to print number is even, else, and there should be a colon here, else print number is odd. We're not going to print 30 as odd because once this if statement is true, we do not execute the else or anything underneath that if block. So let's also check 35. If 35 mod 2 is 0, it's not, so we won't print number as even, but we will print number as odd. But this printing of number as odd over here happens for every number, whether it's odd or even. So the point is that this is wrong code over here on A, right? That's incorrect logic. You would want this indented and you would want an else, which is what this example is checking for you. Versus here, if we plug in 35, is 35 mod 2, does it equal 0? No, it does not. So we will not print that 35 is even. Instead, we will print 35 as odd. And I'd like to point out again, right here where I'm moving the cursor, there should be a colon. Okay, now we're at nested if-else statements, and we're going to look at also multi-way if, elif, else statements. But really, we're going to start with nested if-else statements. The summary here, or the trailer, is you can put anything you want inside an if statement, including many other if statements. So we've seen a program where we can put all kinds of stuff inside an if statement. Here we only put one line, but here inside this else we put 2 lines. But of course I could come here inside this if statement, I can put all kinds of other things if I wanted, right? I can put many print statements. I could put x equals 5, 4. I could then put x plus equals 1, and then I can print x. All of that's happening within this if statement. Not the else, just the if. You can put whatever you want inside an if statement, including another if statement. That's the takeaway here. We can nest our if statements. And what would be the purpose? Why would we want to even do that? And the reason is to capture the logic that we're trying to solve of a given problem. So the inner if statement is said to be nested inside the outer if statement. And even if the inner if statement can have even the inner if statement can have another if statement inside of it, the nesting can just keep on going. There's no limit to the depth of the nesting. So let me open this one up. Here we have if I is greater than k. Then inside that we have it's nested if j is greater than k. So this is nested over. This if statement is inside this if statement. So if I is greater than k, then we check if j2 is greater than k. And if both of those are true, we're going to print I and j are greater than k. And then this else, notice based off of its alignment or its indentation, it's matching up with this if above. It's not matching with this if, it's matching with this if right here. And therefore we print I is less than or equal to k, because I is not greater than k. So this else would be I is less than or equal to k. So let's go through a common example, almost shown in any textbook. And this, man, I want to code this one up because this right here is misaligned also from the publisher. This came directly from a book. So I want to type this up. File, new, save, and let's call this, what is this that we're doing? Score. Okay, let's call grade nested if else. And this is a nasty one, but we'll imagine we got a score, or we ask the user. Let's do this. Let's ask the user for their score. So score equals, we'll do score. Score equals input, please enter your score. And they're going to enter a score from 0 to 100. Let's put that there. From 0 to 100. We're going to scan their score, and we want to print if they got an A, a B, a C, a D, or an F, right? So the code was simply if score is greater or equal to, greater or equal to 90. We want to print, now I won't even assign, I'll just print a letter grade. Print A, you got an A. But now if they did not get a score greater or equal to 90, now we're looking at all other options that now they got something else, which is less than 90. And so now we're within this area of code right here, the else, where it's less than 90. What's my first case I can test for? If score is greater or equal to 80. Well, if now the score is greater or equal to 80, that means you got to be cool. But else, what does the else mean here? This else, let me come back up here. This else means score, I'll just say less than 90. What does this else mean? This means it's less than 80. So if it's less than 80, now we have if score is greater or equal to 70. We could print that they got a C. What does this else mean that I'm about to put right here? It means that the score must have been less than 70. Well, if it's less than 70, what does that mean? It's either going to be a D or an F. So here, if the score is greater or equal to 60, we can print a D And then finally, we get that it's less than 60, so else we print F. So this is the idea. Look how many layers of nesting. So here within this else, we nested an if-else. But then within this else, we nested another if-else. Within this else, we nested another if-else. And finally, within this else, we just printed. The layers that we have of nesting, and to be honest, this is hideous. We're going to show you a better way of doing this one. But this is a classical example because, number one, it's an example that most of us understand. Given a score, determine your letter grade using the traditional scale 90 to 100 an A, 80 to 89.999, less than 90 a B, and so on. But it also is a nice example to demonstrate that nested logic. So here is an explanation of that execution that we just gave to you live as I was coding it. And this is a flow chart for what's going on. So if you get a greater or equal to 90, great, your grade is an A. But else, if that were false, now we're going to check, well, is it greater or equal to 80? If it is, B, great. Otherwise, we have to come and do another nested check. Is it greater or equal to 70? If it is, great, you got a C, and so on. So here's a nice flow chart to really show what's going on. With that in mind, let's see if we can identify why this right here, this code, look at how we've assigned or we're checking the values. Instead of starting at 90, I've started at 60. If score is greater or equal to 60, I put a D. Else, we then check if score is greater or equal to 70, we put a C. Else, we check if it's greater or equal to 80, we'll put a B. Else, and so on. So consider that code, reflect on it, and try to answer these two questions. What is the grade when the score is 95? Go through that. Well, we know the grade should be an A, right? But what's the grade when the score is 95 per this logic? Well, per this logic, the grade's going to be if the score is greater or equal to 60, which is a true statement, we're going to assign the grade to be a D, which is not correct, right? Students would be quite upset if they got a 95 and you assigned them a score of a D. So the logic here is incorrect. And then we're saying else, if it's not greater or equal to 60, we'll check other options. So the purpose here is to demonstrate that the logic is completely wrong on this particular ordering in those Boolean expressions that we made. So the takeaway is we have to pay attention to the logic when we're doing nested if-else statements. So here a short program. Write a program to do the following. Ask the user to enter the grade that they received on an exam. We're going to ask them for their age, and then we're going to print a message to the user based on the following. If they got a 90 or above, and they're 21 or older, we're going to tell them they can celebrate their great score by going out partying. Let's go. Or even if they got a 90 or above, but they're not 21 or older, they're going to go celebrate by going out and watching a movie, which I guess is pretty good. But if they got less than a 90, then we don't want them to give up and be too sad. So we ask them their age and we say, hey, you got to go study. You can't go out and party, but enjoy a beverage of your choice if you're over 21. Or if they're less than 21, we say, drink some coffee while you're studying. Hopefully that will be sufficient. Here are sample runs of that problem. We ask them, what grade did you get on the exam? How old are you? And then we print out, yay, you get to go clubbing, to go celebrate. Or we ask them, what grade did you get on the exam? They got a 97. How old are you? They still got the 97, but now they're less than 21. They're 19. So we say, yay, go to the movies to celebrate. Or what grade did you get on the exam? Oh, they were so close. They got an 89. So they're really, really sad. But how old are you? They're 21. So makes them feel a little bit better that while they have to go home and study, they enjoy a beverage of their choice while studying. What grade did you get on the exam? A 78. How old are you? 18. Okay, bummer. You need to study more. Hopefully coffee will be sufficient. So let's code this up. Let's look how we're going to want to code this one up, and we'll come back and forth between these sample executions and then what we're trying to accomplish. So File, New, Save, and let's call this Study or Party. Let's call it that, Study or Party. And what do we want to ask them? What grade did you get on the exam? So let's get input from user. And what is the input? We'll call it their score equals int input. What was your grade on the exam? And then age equals int input. What do we actually ask them? How old are you? That's a little bit better. How old are you? Question mark. Let's be consistent. I'll put a question mark here. I like colons when a user's entering data, but since they're questions, I'll put question marks. No harm. What follows after we have those two things is we're basically ready to print a single line of output. But we need to now test logically. So print the output, but now we need to do some logical checks. We need to check their exam grade. So if the score on the exam was greater, I'll put greater or equal to 90. So if score is greater or equal to 90, what does that mean? That means they get to go celebrate. They're going to go out and either go clubbing or they're going to go to the movie. But now we need to check their age. So now, check their age to see how they will celebrate. So if the age is greater or equal, I'll say greater or equal to 21, they will go clubbing. So if age is greater or equal to 21, we're going to print out that message. What is the message? Yay. Go clubbing to celebrate. Go clubbing to celebrate. Was exclamation point, exclamation point. I'm just trying to match it. All right. So we're still checking within this if the score is greater or equal to 90. That's where we're at logically. But inside that, we know we're inside it because we're nested over. So now inside that logic, we're checking if the age is greater or equal to 21. It is. Cool. We go clubbing. But now what if they're not? Else, if they are less than 21 years old. So here we have an else colon. I'm going to put a visual space between that print statement and the comment just so it's easier for readability purposes. So else they are not greater than 21 or equal to 21. They're less than. So here, print, and what are we going to print? Still yay. Go to the movies to celebrate. Celebrate. Did I do that right? Go to the movies to celebrate. Perfect. So check out all of this logic. If it's greater or equal to 90 for the score, we're going to celebrate. And all of these two if-else statements, this block, this if-else logical block, it's all indented, nested inside this. That's how you know what happens inside it. So now what about if the score is not greater or equal to 90? That's an else. So else, the score is less than 90. And notice where I want to align this else. I'm going to put it all the way over here, left aligned, to match with the logic of this if statement. This is if the score is greater or equal to 90, and that's left aligned. So the alignment needs to match up. This else alignment needs to match up with this if. So else, what happens now? We need to check, once again, their age. So I'm going to do this. I'm just going to copy paste all of what's inside this if statement here, and I'm going to paste it right here. And now I'm just going to change what I need to change. Check their age to see how they will study. If the age is greater or equal to 21, they will study, unfortunately, while drinking. Else, if they're less than 21, they will study with coffee. So if age is greater or equal to 21, what do we say? We say bummer, need to study more. Bummer, exclamation, no comma, need to study more. But we'll swallow it down. But we'll swallow it down with some And I'll say here, list out your beverage of choice. I'll close the assistant here so we can see. Cool. Else, if they are less than 21 years old, we're going to say, bummer, need to study more, but coffee should help. And we put a dot, dot, dot. So what I want to go over here is to see that all of these lines of code, 21 through 27, they are all indented within this else block. So logically, it's within an else block. And let's actually debug this. When I hit the debug statement, Python's going to ask me to enter the grade. So let's say we enter that they got, I want to enter that they got an 85. And let's continue debugging. I have to step into, so F7, I'll just hit F7 on my keyboard. So score is 85. Age, how old are you? It's asking me now down here. Let's say that they are, let's say they're 22. Cool. So what's going to happen now is Python sees that we have this entire if-else block. Just look at what's happening on the debugger. It's highlighting the entire if-else block. And now it's going to do it piece by piece. It's going to say, okay, is score greater or equal to 90? Well, what was score? 85. Is 85 greater or equal to 90? Nope, that's false. So what's going to happen is all of this is going to get skipped because that's a false statement. So everything inside this if statement up here, which is lines 9 through 16, they will be skipped. And what happens is when I hit F7 and we see that this Boolean expression evaluates to false, what happens is this all gets skipped and the interpreter for Python will come to this else block and will execute this code. So now we're at this else block. Notice it skipped all of this up here. It came to the else block and now it's about to execute that it's within the entire else block, but now we have within there a new if-else block that is indented inside. And we check the age. Is the age greater or equal to 21? They're 22. That's a true statement. It is greater or equal to 21. So we're going to print this statement, bummer, need to study more, but we'll swallow it down with some beverage of your choice. And because this if statement was true, we will not execute this matching else statement, as we've already covered. So bummer, and then the program has concluded. So here's the code that we typed up together, and here is code that I've typed up previously. It should look pretty similar. Maybe I put slightly different wording. Okay, so the takeaway, though, is that also nested if-else statements, they can be quite cumbersome and they can be difficult to read. So Python, as well as other languages, they solve this with what is called a multi-way if statement. Consider that example that we typed up previously, this if-else, this nested if-else statement to determine if you got an A, a B, a C, a D, or an F. And look at what Python allows you to do. These are equivalent. These are both valid syntax within Python. That instead of doing all of this nested, cumbersome, pardon me, but I'll call that trash, instead, we can just use this elif, where we're saying if the score is greater or equal to 90, you got an A. Elif, which really stands for else if the score is greater or equal to 80, you got a B. Else if the score is greater or equal to 70, you got a C. So how would we change this? We don't need all of this stuff. I can just now do an elif, score is greater or equal to an 80. You got a B, and I have to fix all this indentation. And this is going to be elif, score is greater or equal to 70. You got a C. Elif, score is greater or equal to 60. You have a D. And then finally, we don't even need to put an elif here. The final thing is just an else. And so what happens is the Python interpreter is going to look for the first one that is true. This is worth debugging here. Let's run it, make sure it's working. You got a 85, that's a B. Unfortunately, maybe someone got a 43, and it all of a sudden failed. What happened here? Oh, typo. That's why that one failed. Let's do that again. They got a 43 F. So let's debug this. So here, enter your score. And the score is, let's choose, they got a 98. And so as I go through this, score gets saved into 98. Python, the interpreter, recognizes we have an entire block. Look at how it highlights that entire block. This logical if, elif, 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 else block. It highlights the whole thing because it's going to process that entire thing as one big block. So now when I hit F7, and it's now going to check, is the score greater or equal to 90? That's true. So we're going to print A. And as soon as we print A down here in the output, look what happens. We're going to skip all the rest of this. And we're going to come to line 13, which there's nothing there. And then the program is done. Let's actually put here, print now here, after if, elif, else block. And so now let's debug this again with a different value. Let's hit F7 multiple times. Enter your score. Let's put 82. They got a B. So Python interpreter highlights the entire block. We say, is the score greater or equal to 90? 82 greater or equal to 90? No, that's false. So we will not print A. We will not execute what's inside the if statement. And now the interpreter says, cool, let's look at the rest, but one at a time. So elif score greater or equal to 80, is 82 greater or equal to 80? Yeah, it is. So we're going to print B, right? B is going to print, look at the output. B prints right here. But then what happens? What happens is we skip all of the rest of that if, that elif, 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 and those, we skip all the rest of that block because we already found a truth. Once Python finds one truth within an elif statement, it executes what's inside that elif, but all of the other checks and elifs and the final else are skipped. So when I hit F7 now, we come to line 14, and we merely print now here we are after the if, elif, else block. So this is your multi-way if statement. Much preferred, much easier to read than the cumbersome nesting of if-else statements. So why would you use nesting? Sometimes you just have to, based off of your logic. And we'll see that when we come to more complicated programs. Sometimes the multi-way is not going to cut it because you just have layers of nesting that have to be processed in a certain way. But if it is sufficient to use a multi-way, it's so much easier and preferred. So this is our last example, and it's the famous Chinese Zodiac. Maybe you know your Zodiac, maybe you don't. It's a classical example shown with multi-way if, elif statements because it's perfect for that. So the Chinese Zodiac, we're going to ask the user to enter their birth year, and then we're going to display for them the correct Zodiac sign. So problem-solving phase, implementation phase. For the uninformed, which is pretty much me, you have to know this little wheel here. It could have been depicted without in some other fashion, but we have 12 choices. Are you born in the year of the monkey, the year of the dragon, the year of the rat, or the ox, or what have you? How many of us know how we determine, are we the year of the horse or the year of the tiger? How do you determine that? It's actually mathematical, and it's pretty easy. So the problem-solving phase is important on this one. Let's start by asking the user for any year, their birth year. And then after they enter a year, how do we determine that Zodiac? Well, it turns out the Zodiac is on a 12-year cycle. Year 0 was the year of the monkey. Come back to that little wheel here. Year 0 was the year of the monkey. Year 1 is going to be the year of the rooster. Year 2, the year of the dog, and so on. So year 0 is the year of the monkey. When is the next year of the monkey? Year 12. When's the next year of the monkey after that? 24, 36, 48, and so on. So what does that mean for us? Year 1 is the year of the rooster. When's the next year of the rooster? Year 13, add 12, 25, add 12, 37, 49, 61. These are the years of the rooster. So for a given year, how do we find the zodiac? The answer is we divide it by 12 and we take the remainder. If the remainder is 0, that's the year of the monkey. If the remainder is 1, that's the year of the rooster. Because again, year 1 is the year of the rooster. If you take any of these numbers and you divide it by 12, what is 13 divided by 12? It's 1. What's the remainder? There's 1 as a remainder. That's the year of the rooster. What's 25 divided by 12? We're talking about 3rd grade division or 2nd grade division, right? You want to go up and you want to, I'll grab the trusty old tablet, you have 25. You divide that by 12. What's the answer? 2. But what's the remainder? 1. This is the year of the rooster. We'll do one more. It was 49. What's 49 divided by 12? 4. And what's the remainder? 1. That's the year of the rooster. Pretty straightforward once you know that. And so now the code is just a long if-elif statement. So we're going to mod the year by 12. We're then going to check, is that result 0, 1, 2, 3, 4, all the way up to 11? And we're then going to print an appropriate statement. So let me come back to Thani, File, New, Save. Let's call this just Zodiac. And let's hit print. Oh, not print. Let's year equals input. What year were you born in? Were you born in? Question mark. And we could go ahead and get the modded result of that here, or we can just do that within the if statement itself. So I'll do it in the if statement itself. So I'll say if the year mod 12, if it equals a 0, this is going to be, let's make a print statement. You were born in the year of the, and what is that? That was monkey, right? You were born in the year of the monkey. Cool. Monkey. Yay, super exciting. So now what can we do? Well, now it's going to be elif year mod 12 is 1. What year were you born in? You were born in the year of the rooster. And now that we've done an elif, I want to copy paste. This doesn't take too long. So paste, that's number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's go through and change these quickly. 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now I'll put here 11, but I want to show you why that's unnecessary and why this is actually more correct. Just to put else, colon, and I'm going to comment the rest of that line. There's no need to say year mod 12 equal 11. And I want to point this out. It's important here on the tablet. This is a math thing, but it's an important math thing. So let me erase this. If you were to divide something, think about this. If we take x and we say divide x by 12, I don't care what the answer is up here. It doesn't matter to me. Whatever the answer is, I don't care. That's not important. What is important, and x could be some huge number. I mean, this could be some 8-digit number, right? I'm not worried about that. So x could be a big number. Whatever the answer is, it doesn't matter. What I'm concerned with for the purpose of this discussion is when we look at this remainder down here, let's call the remainder, gosh, I want to call it x as well. Let's call it r for remainder. What is remainder going to be, or what are the possible values of remainder? Well, remainder, the possible values for remainder, it could be 0, right? If 12 divides cleanly into x, the remainder absolutely could be 0. The remainder could be 1. The remainder could be 2. It could be 3, right? 4, 5, 6, 7, 8, 9. It could be 9. It could be 10. And then finally, the remainder could be 11. But could you have remainders greater than 11? Could you have a remainder of 12? I'm pausing there for emphasis. If you take 24 and you divide it by 12. Is it possible that you'll ever have a remainder of 12? The answer is no, because if you had a remainder of 12, that means that you could have divided this 12 into that 12. It's not possible to have a remainder of anything less. It's not possible to have a remainder of the same number of the value you're dividing, of your divisor. So here, the remainder, when we divide by 12, we get 2, and the remainder is 0. You're never going to have 12 as a remainder when you divide by 12. The largest remainder will be 11. So if you divide by 12, the possible remainders are 0 to 11. Another question, what if you divide by 28? What are the possible remainders going to be? If you divide by 28, the possible remainders will be 1 through 27, or it's actually 0 through 27, right? You could have no remainder. It could have 27 as a remainder. Let's do one more. If you divide by some number, x, you divide it by 859. What are the possible remainders? It's going to be 0, 1, 2, all the way up to 858 are the possible remainders. So with that in mind, because we know that the last choice here, like I could have put elif, year mod 12 is 11, like hey, else if it's 9, elif if it's 10, else if it's, or elif, or else if it's 11, or elif it's 11. But there's no choice after this. I've gone through all options, 0 through 10. There's only one more choice, 11. So it's better to end it here with an else. And now you could just put else and put no comment on that line. I like to actually put a comment and explain, hey, this else really is checking if the mod 12 is 11. It's good to put that there as a reminder so you know what that final else is checking. And so what's left is just to fill in the rest of what's printing. So we had what? Dog, pig, rat, ox. Dog, pig. I want to finish it. Why not? Rat, ox, tiger, rabbit, dragon, tiger, rabbit, dragon, and then snake, horse, sheep. Snake, horse, sheep. Let's run this code. Let me zoom out just a bit so we can see the full program. And let's run it. What year were you born in? Let's say you're born in 2003. You were born in the year of the sheep. If you were born in the year 2000, you were born in the year of the dragon. Let's say you're born in 1998. You were born in the year of the tiger. Let's do a couple more. You're born in 2005. That is the year of the rooster. 2003 as well. This will cover a lot of the viewers. You were born in the year of the sheep. Pretty basic program, but a nice example of where a multi-way if-else statement will be valuable to us. Because to do this one with nested, oh, that would have been a disaster. Imagine if you had to type here, else, it wasn't 0. It was everything other than 0. And now we need to check if the year mod 12 was 1, and we indent that 4 times, and then we'd have else, and then here we'd have to indent, oh, it's just hideous. Oh, no, I'm getting nauseous looking at it. Of course, it's joking, but that's a disaster. You would never want to use nested if-else statements for this type of a problem. This is a perfect example of where, look how clean it is, how everything's lined up, and it's easier to read, it makes more sense. This is absolutely the preferred choice. The great news, we are done after that problem. This was the end of part 2. What comes next is going to be more fun with nesting, more fun with solving problems with selections. As always, leave a comment, reach out if you have any questions. It's been fun. Take care.